Okay, so in this example, we're going to look at solving a triangle using the law of sines. However, in this case, if you notice, the given information, we are given two sides and an angle, all right? And so we're given side angle, and this is the notorious side angle, two sides and an angle opposite one of the sides. This is the notorious side angle case where you might have no solution, one solution, or two solution. Okay, so let's go ahead and let's try to solve this one here. All right, so um, there's no way around it. I mean, there's really nothing we can do at this point other than find angle B, right? So let's start there. So we're going to solve for angle B, so I'm going to use this proportion. So I have B, so sine of B over side B equals the sine of A over side A. Okay, and so I find that the sine of B is equal to side B, which is 7.9, times the sine of 51 degrees, all divided by A, which was 6.5, and so B is going to be equal to the sine inverse of that quotient, 7.9 over the sine of 50 times the sine of 51 degrees over 6.5. Okay, so punching that into our calculator, we find out that B is approximately, let's see, I guess to the nearest, let's do one place here. So let's say 70.2 degrees. I'm sorry, 70.8 degrees. Okay, 70.8 degrees. Okay, so now comes some explanation. All right. Now, because we are using the inverse sine to find an angle, this ratio here, let's actually come back up to this, I guess this would be the second line down here. So this piece right here. Now, this ratio right here is a positive number, right? And we know that when we're solving for an angle for sine, if the ratio is positive, we know that there's two possible answers. And those two possible answers are angles that correspond to quadrant 1 and quadrant 2, right? Because that's where sine is positive at. Now, because that's the case, it's possible that we have an answer here, an angle that's in quadrant 1, which is an acute angle, right? Or, let's just call that B. Right? Or we have an angle that's in quadrant 2. Let's call that B prime. Okay. Both of these angles are very possible because they are within 180, meaning that if I found the first angle and added it to the given angle A, then that would leave some room there for a third angle that would add up to 180 for a total angle. Same thing with possibly angle B. We'll check here in a second. B prime, I mean. If I take B prime added to A, hopefully there's some left over for an angle C to create a second triangle. So this is how we get two possibilities. It's mainly because when we take the sine in, when we look at this setup right here, the sine of an angle is a positive number, that positive number in 1 or 2. Okay? All right. Now, so what happens then is that really this inverse that we found here, that turns out to be the reference. So the sine inverse of that ratio is our reference angle. And so for our first answer, B, because we remember that if the reference is in quadrant 1, then it's the same as the angle. So this B reference is my first solution B. Okay, so now I need to go find B prime. And so how do I find B prime? Well, I notice that this piece right here, that's my reference. And so I take 180 minus the reference, which is the same as B, so 70.8 degrees. And I find that my second angle is going to be approximately 109.2 degrees. Okay. So we have two triangles. So we have two triangles that we need to solve. We have a triangle that involves B being 70.8, and we have a triangle that involves B prime equaling 109.2. Okay, so I'm going to draw a little dividing line here as we go along. Okay, so now I need to find angle C. So if I know that A is 51, B is 70.8, what I take 180, I subtract off the sum of those two angles, so it's 51 degrees plus 70.8 degrees, okay, and we run those into the calculator, and we get 58.2 degrees. Okay. Now let's look at what happens if we use B prime. So now it'll be a C prime. Okay. So if that's the case, we do the same thing. So we take 180 degrees, subtract off the sum of the given angle A, which is 51, plus B prime, which was 109.2 degrees. And here we get that this is approximately 19.8 degrees. Okay, so now what we need to do is we need to find C. Okay, now C, let's start with side C. That's going to be equal, using the law of sines. It's going to be approximately here. It's going to be, and what we're going to do is use A because that was given to us, right? So we're going to use 6.5. 6.5 times the sine of A, which was, sine of C. C was 58.2, divided by the sine of A. So the sine of 51 degrees. And we get this to be approximately, let's see, to one place, 7.1. Okay, and that was feet. All right. Now, using the law of sines, let's find little c prime. Little c prime, that's going to be approximately, let's see, it's going to be approximately, we're going to use A again, so it'll be 6.5 times the sine of c prime, which was 19.8 degrees, and that's all going to be divided by the sine of 51 again, 51 degrees. And so if we run that into the calculator, we get that this is approximately 2.8 feet. Okay, so let's see. Let's double check. Now, the way that you double check your answers, remember, it's still possible that we only have one answer, no answer, or two answers. Okay, well, for sure there's at least one answer, okay, because we were able to come up with at least with two possibilities. So there's going to be at least one, right? But there might be two. So let's run through the cases. So what I do to check this is I just want to verify that everything checks out. And what I mean by that is that the largest side corresponds to the largest angle, the middle side corresponds to the middle angle, and the smallest side corresponds to the smallest angle. Okay, so let's run through it. let's start with all our B's and C's first. So, or let's see. So, the biggest angle, if I look at the A, B's, and C, not the primes, but the A, B, and C, the biggest angle was which one? B, right? Angle B. Was B the largest side? So looking at all the possible sides, yes, B was the largest side. The middle angle was C, and was C the middle side? Yes, C was the middle side, and so A was the smallest angle, and so A is the smallest side. Okay, now let's see, what about the B primes? Well, the B primes, see, B prime was once again the biggest angle, so biggest side. But this time A was the middle angle, and A is the middle side, and C is the smallest angle at 19.8, and C is the smallest side. C prime is the smallest side. So everything checks out, and we have our answer. Now, how does this all work out? Well, the idea here, when we're given an angle and two sides, if I come back up here to our original triangle with the diagram, the idea is that angle A is fixed, so we can't change angle A. So in other words, you see these two sides, this side here and this side here. I cannot change those. I can't bring them closer together, and I can't move them farther apart because the angle 51 is fixed. Also, I cannot change the lengths of these sides. I can't change the lengths of side BC or AC, right? So in a sense, I can only move those around. So the only side that can be moved, right, is going to be side BC. And the way that we do that is we actually bring that closer to A. So I bring B closer to A. So I'm going to move this piece like this way, like that. And so by moving it that way, let's say I move it just a little bit closer. And the idea is I swing this piece here, this point B, I swing it until it touches the curve again. So it looks like it might touch again, like maybe right here. And so I connect now this side here, C, I connect it with that piece like that, right? And so as you see this, and we get a new triangle here, this smaller triangle, right? We get the smaller triangle, and this right here is my B prime, and this right here is my C prime, right? And that's the idea. And so notice that the angle of 51 degrees, which is right here, that's still the same. And supposedly this side right here is fixed, this is fixed. All that changed was angle B and angle C. Okay? And that's what we have there.